Okay, this time around we're going to review how to implement the Subclass Sandbox pattern. Here's the idea of Subclass Sandbox. We are going to add a whole bunch of entities to our game. So we added coins last time, but if we want to add a lot of entities, there's a lot of code that they share in common, which means that inheritance would be a good idea. So we're going to create an abstract class called entity. Remember, abstract means that you can't create an instance of entity. It's a class that only exists to be extended. Then we're going to create another abstract class called moving entity. So far we haven't gotten to Subclass Sandbox. Here's what Subclass Sandbox is. The idea is we're going to give moving entity an abstract method called move. What that means is that all of its children are going to be forced to implement their own move methods. But instead of requiring them to come up with some complex code to do movement, moving entity also provides a whole bunch of pre-coded options for how to do different kinds of movement. So here in my example, we've got random movement, move random towards, move towards, etc. So inside popstar, for example, when popstar overrides the abstract move method, it doesn't have a lot of complex code. Instead, it just chooses one of these pre-existing options. So it'll just run move random towards, which it's inherited from the parent. So that's Subclass Sandbox. A review from last time, one of the design principles we're using is we're going to put variables and methods at the highest level class for which they make sense. So entity should contain XY coordinates, it should contain the sprite sheet, and so on. Moving entity should contain everything that pertains to movement, so X speeds and Y speeds and so on. And then Wumpus and Popstar maybe don't even need any of their own variables at all because everything that's relevant is getting inherited from above. In terms of how your constructor should look, this is just an example. Your Wumpus constructor probably will take more inputs, but the idea is if you're going to construct a Wumpus, you're going to give it its starting XY coordinates. But the XY variables aren't actually declared in Wumpus. They're inherited all the way from entity. So in order to set them, you're going to call the parent constructor by using the super keyword. So the Wumpus constructor takes those inputs, it calls the moving entity constructor, and tells it, here's the XY coordinates that we're going to construct ourselves at. Then moving entity takes those same coordinates, and it calls its super constructor to entity. And entity actually declares them, entity actually assigns them because that's the class in which X and Y are declared. So the general rule is, any variables that are declared in a parent class, you need to pass that information to the parent constructor until eventually you get to the class for where they're declared. Otherwise, you can just go ahead and have your constructor assign those values if that's the class which has declared those variables. So I'm going to go ahead and use coin as my template here to create an abstract entity class. So I'll say new class entity. I'm going to mark it as abstract. Here we go. So anything that's an entity, I want to think what are all the fields that all entities should have. So anything that's an entity should have an XY coordinate, probably a width and a height. Value, that's specific to coin, so I'll keep value there. I suppose we might want to consider the possibility of having entities that don't actually visually display, in which case they wouldn't need a width and a height. But I'm going to assume that all entities are things that are actually going to display. So let's see, our entity will definitely need a sprite sheet. So I'm going to cherry pick this off here. It will need a tick count and a level. So let's get those ones as well. Alright, so we'll need to have a constructor and some getters and setters. So let's generate a constructor. So I don't want to construct it with a width and height. I do want sheet. I don't want tick count. Alright, there we go. So there's my constructor. Once I have my sprite sheet, the sprite sheet is what can set the width and the height of the entities. So this dot width equals, sheet dot get width. What's it called? Get sprite width. this dot height equals sheet dot get sprite height. And then tick count will initialize at 0. All right, I have these all marked as private. That means they're not even accessible to the children. Some of them, oh, and I definitely don't want to make my x and my y final because I want my entities to move around potentially. So we could make them protected so that way they can directly access their own values. I think that's probably what I want to do for x and y. I think that's probably what I want to do for all of these. We could consider later on whether or not we've made a poor design choice by doing this. Let's go ahead and make getters and setters. Definitely for height, for level, for width, for x and y. That seems fair. All right, so then coin will extend entity. We don't need to give it its own sprite sheet now. And instead of assigning x and y here, what we're going to do is we're going to call our super constructor, which is the entity constructor. And it looks like the entity constructor expects an x, a y, a sprite sheet, and a level. So here I am back in coin. So x, y, sprite sheet we'll do in a second, and level is level. We don't need to assign width and height, but this dot value should be value. So this is greatly simplified coin, which is the whole point in doing this. Now coin only has fields that are unique to being a coin, the coin's value. Everything that's related to the fact that a coin is an entity in the world, those are all contained inside entity. Okay, so how are we going to deal with this sprite sheet issue? So we could just pass our constant sprite sheet here. So for example, we could say private static sprite sheet. Well, let's make it final. Sheet equals sprite sheet dot tile sheet. Okay, so what's this doing? The fact that it's a static variable means that it's a sprite sheet that is a class sprite sheet. So every single coin doesn't have its own sprite sheet. Instead, there's a single sprite sheet that's shared in the class. And what we can do is we can pass that shared, pass a reference to that shared sprite sheet up to the super constructor so that our coin, when we want to know what sprite sheet does it have, we're pointing to that one. All right, so far so good. We need a render. We don't need all of these getters and setters anymore because these are all getting inherited, but we do want a set value, and we probably want a get value. I don't know why we don't have a get value. Okay, so let's think about tick and render. Anything that's an entity in the world should have a tick and render method. That's like the most important thing, and we forgot about it. So I'm going to make them abstract, which will force the children to implement a tick and render. So public abstract void tick and public abstract void render. And remember, render takes a screen as an input because we're rendering to a particular screen. All right, so now coin is still okay because coin is actually implementing render and tick. And I think that's all we need to do. Great, so let's just run it to make sure coins still work, that we haven't broken anything. Cool, our coins are still there. All right, so now we're in a nice position to extend the hierarchy. So we're going to make a subclass of entity that's specifically for moving entities. So I'm going to make moving entity. It's going to be abstract. It's going to extend entity. All right, so the fact that we are extending entity means we inherit all that stuff for free. I just went ahead and created a constructor, and it calls the super constructor with the information that it needs. So moving entity only needs variables that are unique to the fact that it's moving. So I think we're going to have an x speed and a y speed, at least. And we can figure out what else we might need later. I'm just going to leave this as is. Notice that even though we're inheriting the abstract tick and render methods, because moving entity is also abstract, those tick and render methods are still sitting there as abstract methods. So anything that extends moving entity now is going to be forced to implement those abstract methods. All right, so let's make our first enemy. I'm going to make a class called Wumpus. So Wumpus is going to extend moving entity. And I'm going to add a constructor for Wumpus. And I'm also going to add the unimplemented methods of tick and render for Wumpus. All right, so Wumpus, when we construct it, takes an x, a y, a sprite sheet, and a level. I don't think we probably need anything else for Wumpuses right now. Tick. So the Wumpus's tick method, let's just do tick count plus plus. You know, since this is something that we want all entities to do, it actually might make sense for us to have a default tick implementation and then to run the parent's default tick implementation. Maybe we'll come back and do that as a revision later, though. Okay, render. So how are we going to... You know what? Maybe we'll do that... Yeah, we'll do that as a later step. So render, we'll say screen.render. We're going to render at our own XY position using our own tile sheet. And then we'll need to know what tile row and tile column we're going to render ourselves from. And then we'll have a mirror direction, which is screen.mirrorDirection.none, because we don't want to mirror at all. Let's come back to tile row, tile column. Or maybe for the moment we can add some private ones here. So private, static, final, int, Wumpus, tile row. I'm just making up some numbers here. Wumpus, tile, column. Okay, if you're thinking, wait a minute, anything that's an entity should have its own tile row and tile column for display, you were thinking right. So we're probably going to end up refactoring all of this to go back up inside entity eventually. But for the moment, we can keep them here. So Wumpus, tile row, Wumpus, tile, column. So now we just need to do the same thing we did for coins. We need to provide a way for the level to actually contain other types of thing, like Wumpuses. And we need to provide a way to add them to the level. So let's go to the level class, which is here. Right now, we've got what? We've got a player and we've got an array list of coins. So, excuse me, instead of an array list of coins, let's make an array list of entity, which I'll import. And instead of calling it coin list, I'm going to call it entity list. So now, no matter what our entities are, they can all go in this list. Here under tick, instead of ticking through all coins, I'm going to tick through all entities. And I'm not going to call it coin, I'm going to call it entity. And then instead of rendering all coins, I'm going to render all entities. And this works because we made render an abstract method inside entities. So we're sure that anything that's a subclass of entity is going to have a render method. This uses polymorphism, if you remember what polymorphism is. Okay, so what's the only thing we're missing? So we've got... Where's all my coin? All right, so we got add coin. Let's provide a way to add Wumpuses now. So public void add wumpus. It's going to be just exactly the same. We're going to add a wumpus at a particular XY location. So I'm going to say wumpus w equals new wumpus. And we're going to add it at XY. What does a wumpus expect in its constructor? A sprite sheet and a level. Okay, so you know what I'm going to do for wumpus is I'm going to do the same thing I did for coin. So private static final sprite sheet equals sprite sheet dot I think, well, I don't know. Let's find our wumpus inside the tile sheet sprite sheet. Or I'm just going to see what's at this particular spot. So now instead of taking sheet as an input here, sheet is coming from this constant that's our class constant. So now back in level, I don't need to give it a sprite sheet. However, we still do need to give it a level. And the level we're going to give it is this, because we ourselves are inside a level. I'm going to import wumpus. Now I'm going to say entity list.add w for wumpus. Great. So final thing, inside game, we're adding some coins. Let's add a wumpus. So level.add wumpus. I'm going to add it at 10 times 16 by 10 times 16. And let's run the game and see what the wumpus looks like. Over at 1010. I don't see my wumpus there. So let's try and figure out why I don't see the wumpus. So one possibility is, let's look at render. So what if we're rendering all the tiles after we render the entities? In that case, we would be rendering the tiles on top of the entities. It doesn't look like that's what's happening. Here I've got render tiles, and then afterwards I'm asking the level to render entities. So that seems probably not like it's what's happening. So we're rendering all the entities in the player. I guess let's look in the sprite sheet, because that's probably the other thing that's happening, is I didn't actually choose my sprite. So here's the sprite sheet I'm using. I think I'm going to have this little bird thing be the wumpus. So this is at column, I think it's at column 16, and it's at row 7. So that's what I'll use. So back here for wumpus, where's wumpus? I've got row, I said was 7, column was 16. Now let's go ahead and run it. And there it is. There's my little wumpus. Cool. So we still haven't done Subclass Sandbox in order to provide movement methods, but come back next time and we'll do that next time.